Hello everyone, we are from ECE department in Vikas College of Engineering and Technology.
We are design LCD display with Arduino.
Quick components: Arduino, LCD display, breadboard, jumper wires, USB cable. Now we move to connections. Take Arduino and take LCD display and connect with the 4 pins with jumper wires. LCD ground to Arduino ground, LCD VCC to Arduino, 5 volts, LCD SDI pin to Arduino A4 pin, LCD display SCL pin to Arduino A5 pin, USB cable to Arduino and laptop. Now upload the coding to the Arduino and we will display the program VCTN, ECE. Basic monitoring system installation. Required components: Arduino, MPU 6050, breadboard, jumper wires, USB cable. Place the MPU 6050 sensor on the breadboard. Now connect VCC pin to 5 volts. Connect ground pin to ground pin in Arduino. Connect SCL and SDI pin in serial plug in Arduino. Connect Arduino to USB cable to system. Now upload the code in Arduino. Now we can see the output. We can see the acceleration and gyroscope and angle between the X and Y. It will change continuously by moving the sensor and real-time applications, smartphones and tablets and drones.
Now we can see the IR with the Arduino.
Required components: Arduino, breadboard, LED, IR sensor, jumper wires, USB cable type B. Now we go to connections. Take a breadboard and Arduino. Place the IR sensor on Arduino. Connect the IR VCC to Arduino 5. Connect the output IR to 13th pin. Connect the IR input ground pin to ground pin. Place the LED on breadboard. Connect the LED anode to 2nd pin. Cathode to ground. Now take the USB cable type B and connect the laptop. This is the program of the IR with the Arduino. Applications of the IR sensor: obstacle detector, remote controller, motion detector, temperature measuring.
Now let us go with piezo buzzer.
Components required: Arduino, breadboard, buzzer, jumper wires, USB cable type B. Now we can move with connections. Place the buzzer on the breadboard and the positive end of the buzzer to pin 8 and negative end of the buzzer to ground. Connect the 5 voltage of the breadboard. Connect the ground pin to the breadboard. And now connect the USB cable type B to. This is the program of the buzzer and Arduino. The real-time applications are doorbell system and car package sensors.
Now let us go for stepper motor by using Arduino Uno.
Components required: Arduino, breadboard, jumper wires, potentiometer, servo motor, USB cable. Let us move for connections. Place the Arduino on the breadboard setup. Connect the Arduino voltage to breadboard positive. Now place the potentiometer on the breadboard. Now connect the servo motor on the breadboard. Connect the potentiometer left pin to 5 voltage. Now connect the potentiometer right pin to ground. Connect the servo motor red Y to 5V. Connect the servo motor black Y to ground. Connect the servo motor signal Y to digital D9. Now connect the USB cable type D to laptop. Now upload the code to the Arduino. Today we can design the digital outputs. Components required: LED, resistor, jumper wires, Arduino Uno, breadboard, USB cable. Move on to the connections. Take a breadboard and place the LED on breadboard. LED cathode. Connect Arduino pin 13 to LED anode. Connect ground of Arduino to resistor of another end. Take a USB cable. Connect to the Arduino. Now we can observe the output of LED turns on and off continuously. Arduino Uno provides the digital output to control the LED.
Use of the experiment. This experiment is the
To understand how the digital output device works with the microcontroller. Today we are going to see about serial bus. Required components: Arduino, breadboard, push button, resistor, jumper wires, USB cable. Now we are going for connections. Place the push button on the breadboard across the center
terminal of the push button to voltage of the Arduino.
Connect the opposite terminal of the push button to digital pin P2 of the Arduino. Clear resistor between digital pin and ground. Arduino ground to breadboard.
This is the program of the serial bus. This is the output of the serial bus.
Real-time application of the serial bus is home automation, IoT projects.
Components: Arduino, switch, LED, 2 kilo resistor, 10 kilo resistor, breadboard, jumper wires. Now we move to connections. Place the push button on the breadboard. Place LED on the breadboard. Push button to the 5 volts in Arduino. Connect one end to push button and another end to digital pin 5. Other end of the push button to digital pin 5. Connect the 10 kilo resistor between digital pin 2 and ground. Connect the end of the LED to digital pin 13 through 2 kilo resistor. Connect LED cathode to ground. Connect Arduino to computer.
We have designed analog inputs using Arduino Uno.
Components: Arduino, potentiometer, jumper wires, USB cable, breadboard. Now we go to connections. Place the potentiometer on the breadboard. Connect the left terminal of the potentiometer to ground to the Arduino. Connect the right terminal to the potentiometer, ground to the Arduino. Connect the middle terminal of the potentiometer, analog pin A0. Connect the Arduino Uno to the computer using USB cable and upload the code analog input program and counter. Required components: ultrasonic sensor, breadboard, Arduino Uno, jumper wires, USB cable. We move to connections. Connect the VCC pin to the ultrasonic sensor to 5 volts pin. Connect Arduino ground pin. Connect the trigger pin sensor digital pin 9 to Arduino. Connect echo pin sensor to digital pin 10 to Arduino. Now upload the program using USB cable. Now we will upload the code in Arduino. Output. Sensor sensors are between the hand and the sensor between those distance is covered and display in pointer. We use of this experiment to understand the sensor and digital sensor using Arduino. Real-time applications: obstacle detection and in robots.